Hello and welcome to the fourth video in this Java series for beginners. In this video we're going to be looking at Boolean expressions and how we can use
So I'm going to make self.activeBook equal to whatever that ID is. And let's see. So the user has a library of books they can add or remove from. We did that. Setting a book as active. Okay, and then remembering where a user left off. So we've actually taken care of that already implicitly in our book class. And then the reading application only displays a page of text at a time. All right, so then here we can say define display page. And actually we don't even need the ID of the book because we already have the active book ID, right? And so what I'm going to do is I'm going to go into my collection and I'm going to get the active book like this. So blah, blah, and I'm going to click, or I'm going to do dot display page. And then of course we also have this turn page that I could just code up as well. So you get the idea, but so we want to, turn that page. I do think that some drawbacks here are that, okay, so one thing that we could have done is instead of this active book, instead of saving the ID, we could have saved the book itself. And I think from a Pythonic standpoint, that might make sense. But then in the future, if we're using some sort of database or something, an ID would make more sense because that's easier to store in like a table. And if, and okay, also for this display page, you might see that we've called this display page and turn page up here in the book. And the reason why I did that rather than just call like self.book.content last page, like book.last page or something, was because I think that, like, for example, this should be independent of how we implement the book, right? So we want to keep those as kind of separate blocks as possible. And so here, what this allows me to do is when I go back to my book, like if I decide to scrap this implementation, implement something else, I know that I would just have to implement the methods display page and turn page for that to work. And like these functions should work.
This looks good to me. I like the start. I think that this definitely lays out the foundation of what I was looking for with the requirements of this application. So nice work with this. Couple quick follow-up questions before we kind of branch into more of an algorithms type question as the follow-up here. One question is, let's say you have an older reader and their vision isn't as great, so they need to make the size of the font bigger. So kind of keeping that in mind that you might have this variable font size, how might you, I guess, refactor or change or modify your current structure? And you don't have to actually write code here. Let's just discuss this to account for that increase in size.
So when we increase something in size, like I'm just thinking about intuitively on our like phone screens or something, that tends to shift the content, right? So like some page that might hold 100 words or 100 characters at, a small font size might only hold 50 when we double that font size. So for the book, instead of having this list, what I might do is I might just save the entire book as a string. And so I would, let me just edit this in here because I think it's easier to visualize what I'm saying. But so I might have like a font size equal to, I guess we could just use like the traditional like 12-point font or like whatever. But when we have this font size, we could come up with some sort of characters per page calculation, right? And so that would be based off the font size. So calculate. So this is going to be pseudocode now. This calculate doesn't actually exist, but calculate based on that font size. And I'm commenting it out so it doesn't have any errors. But then when we do calculate that, then what we can do in order to get our, in order to get this display page thing would be, instead of indexing into this content, which is now just a long string of characters, what we can do here is we can return, we would have to do some sort of calculation, right? So we would need to, we have this characters per page, and we can multiply that by whatever the last page is. And so this would give us like kind of the starting index of this long string of characters to start the content of that page. Start index would be this. And then what we would want to do is, what we want to do is then return the self.content from that start index until the start index plus the number of characters on that page. So that would be our end index. So actually, let me just write that out to make things a little bit more clear. So now, essentially what I've done is we have this variable font size, which we can calculate characters per page, depending on that font size. So that might be more characters or less characters, depending on how big the font size is. And then our content, instead of a list of strings, is now just a really long string of characters. And I guess some assumptions that I'm making here are that this would just be approximate. So for example, if we had a /n, which is like a line break, right? That might just end up counting as a character or two characters. But the assumption is that that would be approximate per page, or maybe that we're using some sort of like monospaced font or something like that. But essentially, now that we have the characters per page and then just a long string of characters that represents the content, we can index into that content depending on, like, based on the last page that we know. And so what's really cool here is that when we do turn the page, we can just end up calling this. So this is kind of that granularity that I was talking about. Yeah,
that makes a lot of sense to me. And definitely you see the advantage of having that function that you can change by having to implement something different.
Right.
One last quick, I guess, follow-up, and then we'll move on to the algorithms portion of this interview. I'm just trying to think, at a high level, let's say that we had multiple users in this system, and they all shared books. So like, they might all share the Harry Potter books or something like that. Like, books are common among all of them. How might you modify this, given that, some of these qualities of a book might be shared between users because they're all trying to access that same book? Does that make sense?
Yeah, so, yeah, for sure. So I think that when we start to, have like multiple people involved, like these books might get stored somewhere, for example, in like a SQL table, right? And so then when that happens, we would still want to maybe store like the ID, the title, the content in that table. Now, the only changes would be that these sort of customizations are per user. But the book and the content, those are for this entire group of people. And what we can do, I think, is instead of this ID counter being like library specific, we can start identifying books by their IDs on a more like global scale, right? And so, this was kind of just a hack to make this ID thing work and be independent and be like unique. But for example, when you put something into a SQL table, you can also have an ID associated with those entries. And so maybe when we add to the collection, if we see that the title and the content is already in the table, then we instead just return the book that's already in that table or something like that.
Yeah, okay. I think that makes sense to me. Cool. I'm happy with this discussion. I think that we can move on to the second portion. I guess, do you have any, last questions on this before I move on? Or last things you want to say?
Yeah, so no last questions. I think that the last thing I want to say is also, like, it would really depend on, like, how you implement this, like, group of people, right? Like, so my immediate thought was, like, a SQL table, but that doesn't have to be the only way. So, yeah, I think...
Okay, cool.
I think it would depend on that.
All right, awesome. Let's switch gears, and I'm probably going to just comment this out in case you do want to run some code and there's any errors or issues in this. So I'm just going to comment this out, but I'm going to leave it here just so we have it to look back at. And I'm going to just indent this a bunch, and we're going to just start at the top of the screen. So don't mind all the stuff at the bottom. All right, so another important component of our book reading system, and this is completely independent, you don't have to reference any of your past code, is, I mentioned this is for short stories, and you could have independent indie authors, adding these short stories. So they're not going to be, the classics. They're not going to be those types of titles. They're probably going to be smaller authors. So one thing that we want to avoid in this system is plagiarism. So my task for you is to design an algorithm that would be able to detect the two most likely books that would have plagiarism in them. So like the two most likely books that pop up as a match for potential plagiarism in a library. And we can define most likely as meaning they have the longest shared common section of text. So we have a library of books, and we're looking for the two that have the longest shared common section of text. And we specifically might want to know how many characters that section of text is. So you can imagine if it's sharing a single word, obviously not an issue, but if it's sharing 6 paragraphs, that's going to be a problem. So does that make sense?
Right. So just to clarify some things, what Keith really means here by substring is that, for example, if I have a string such as learning, what are substrings of this? Well, one possible substring is learn. Another possible is earn, because these are strings that are using characters that belong to this string, learning. Another possible one is earning. Oops. Now you might say, okay, Kylie, all of these are consecutive in terms of the characters. So here, all of these correspond as characters that are next to each other. But in this specific example, Keith is not actually asking, okay, it has to be a consecutive substring. Instead, what Keith is asking is just any substring, which means that as long as the letters are in the correct sequence, you can skip characters if you want to. So for example, here, leg would actually also be a substring, or an. So for example, right here, we have earn as a substring of consecutive characters, but down here, I could rewrite it as a substring where there's actually a gap of 2 characters in the middle, but this would still be a valid substring. So it doesn't have to be consecutive, we just need all the characters to be in order from left to right. Let's see, let's start off with kind of a naive solution for that. Well, one thing that you could do is literally come up with every single combination of like substrings for both of these, and then compare those and see which 2 substrings are the longest, right? But there's a lot of different combinations for substrings, and so I think that we should come up with a more elegant solution. Let's see. So one thing that I'm thinking is we should have pointers that start at the beginning of both strings, and kind of move along until one of them detects a shared character. So, or like until one of them detects like the first shared character. So here actually, like I would say the first shared character is H.
Yep.
Right. And so here we would have like the 2 pointers kind of be this. Maybe I'll go from the bottom. But here and here, right? And so we look at the next character and we realize, okay, they're not the same, so then we want to keep going. But one downside of this is that, well, okay, what if I want to start comparing from here and here, right? Okay, and then I move it over and like these two have like 2 shared characters. So I think that there's still this question of there's a lot of different combinations here. So
I think you're on the right track there. I like this.
And then
these
okay,
thoughts
so
so
like,
far.
yeah. Okay. Yeah, so I know that here I want kind of these pointers that are moving, and then I just want to be able to align them, right? I think that's the key here is this alignment. And so now I think we just have to figure out how to make that alignment work. I'm kind of thinking like one thing that we could do is kind of have more of a base sentence, and then one where when we have like, so for example, if I made this my base sentence, then in the other sentence I would want to search this sentence for each character. So if I have the I here, then like my first I would start looking from here, and then maybe I would start to look from here. Right. But I think that would end up also being kind of long, because for every single character in here, you would have to iterate through this entire thing and do the whole matching process. And so does that make sense why that's like maybe not the most optimal solution?
Yeah, that makes sense. And I guess what would be the runtime of that?
It would be O of n squared, because, well, I guess if we have one sentence O of n and one sentence O of m, it would be O of nm, because for every single character we have to run through the other string m times. And actually, okay, so like if my base sentence is like what is the worst thing that can happen is like a base sentence like this, right? And then you're searching. The worst case example would be like something like this, right? Where like if I have an I, okay, well I have to go through each of these. And so yeah, I guess we would have to go through until like they don't match anymore, but then that would just be the very end of this. So like maybe I can add like an A at the end of that. So then I would actually, okay, so then I would say it might be O of n squared m, where n is the
Yeah, I
shorter
think that makes sense to me.
I think that we should come up with a different solution. I'm trying to think of how dynamic programming would work, because I do think that this might be a dynamic programming problem. I'm not sure of how to formulate it.
Yeah,
as
let's I think that you're
currently.
onto something here. I think I'm trying to think of a good ways to kind of kick you off here. I mean, I would say let's just let's assume that this is dynamic programming. I think as a good starting point, maybe we can talk about subproblems here and try to define that, and maybe that will help us get to our solution. Or also maybe just define a base case, and maybe that will help us get to the solution. So I think let's assume that dynamic programming can be used here.
Yeah.
Let's maybe just start trying to figure out subproblems and maybe a base case.
Yeah. Yeah, so I definitely think that the base case would be pretty simple, and it would just be if there is a match, right, between the two, like if the two sentences equal another, that would be, okay, let's think about all the possible base cases. So it would be if there's a match, or maybe we've iterated through everything that we can, and we're comparing like an empty string to non-empty, or even empty to empty, which is when we would know that we're at the very end, right? Yeah, so for example, with this match, I mean by like read to read. Like that would be an exact match. So I think the difficulty of this problem is that we can start anywhere in the texts, right? And I guess if we were trying to recurse through this, or if we were trying to go through this with dynamic programming, what I would kind of want to do is say, okay, either like S is the start of some substring in this sentence, or it's not, right? And if it's not, then we want to move over and we want to say, okay, well then is like H is a substring, or the start of a substring from this other sentence, or it's not. And we want to kind of continue that process. And so if, for example, H is a substring, then we would want to figure out what the longest matching one is, and then that would essentially like skip us over a few blocks. And so I think another way to kind of formulate this might actually be like how many characters can kind of almost subtract from the two.
And I might jump in here. Just, I think you're on the right track, but I might provide a little bit maybe of more of a launching point, just because I want to be considerate of our time here. I think you're on the right track. I think that let's maybe try to define this like with a single line expression, like a single line recurrence type expression. Because I think that if we can build up subproblems to that final state, that will help us. So let's say we have sections of text A, and I'll put this in quotes here. We have A is one of our sections of text, and B is another one of our sections of text. And basically, that could be hello world or something, and world, just world or something like that. We can assume that basically what we could start doing here is we can imagine that we wanted to find the longest match between A and B. And you could define that as from character index 0 to character index 0 here. So like the longest common subsequence here, or substring of A, B, 0, 0 would be our kind of goal state, because we would want to find, if we're working backwards, let's say, we want to find all the way to the beginning. But to help us get there, we could probably see if, what is the longest substring at different indexes. So if, maybe index 3, index 5, so like this would be the, I guess, last character, 5 would be like the last character of B. And I guess keeping this in mind, can we define this in such a way where we can define an equation that would help us work up to that final goal, which would be the entire sequence?
Okay, so if we're using kind of these A-B strings as example, let's define some like find longest substring or something. And we might have string A, string B, right? So, and you're saying, okay, let's do index A and index B as well and start those off with 0. That would be our recurrence relation. And so I guess what we'd want to do is find the longest substring between
Yep.
these, and we want to increment
Yep.
one or the other.
Yep.
Right.
Mm-hmm.
So like that. Or if string A equals string B, then what we'd want to do is find the longest substring.
Mm-hmm.
We want to increment both of these indices, apparently. Oops, sorry. So I meant string A at index A and string B at index B, like this. So then we'd want to increment both of the indices, and we want to add 1, right? Because this means that we've found a starting match. And what we want to do is actually take the, so here,
And if you want to just write pseudocode here, it's fine too for me.
Possibility.
Okay, that makes sense to me.
Yeah, so let's just do all these possibilities. And so then if the 2, then we have this like third possibility, right? And what I would want to do is take kind of the minimum. Why is this giving me an error? Oh, so then I would want to return the max of possibility 1, possibility 2.
Yep.
Okay, let's write pseudocode. Possibility 1, possibility 2, and then possibility 3. Only if
makes sense to me.
If applicable. And then with our base case, we said that it would be if one of them is at the end. So let me add that in here. So maybe like if IDX A is equal to the length of string A, then we want to return 0. Or here, or IDXB is equal to the length of string B. Yeah, so then for our longest substring, this makes sense now because with each index, we have the possibility of shifting it over 1 and trying to compare this sentence with this entire one, or shifting the other one over 1, comparing those two indices, or those two substrings from there on. Or if they are a match, then we also have the third option of moving both of them over. So actually I should go from here. And then because this find longest substring repeats all of that on the next character for those two, then we repeat that process again and we add 1 every single time to that. So I think logically this makes sense. Now, one thing might also be that we start to kind of recurse a lot on the same indices, right? Because we're trying all these different combinations, and if we move them both over by 1, then we kind of are iterating over through them a lot. So I think that one thing that we could also do is implement some sort of memoization. So here, like maybe, hold on, I lost the, oh, here we go. Okay, so then, like, if the memoization is none, then we might want to start this with some sort of, it could be a dictionary. I think that also what could make sense is like a list of lists, right? So like maybe -1 because there's no such thing as a -1 length substring. And I'm gonna multiply that by the length of like string A, for example.
Yep.
And then this whole thing by the length of string B. And so essentially I have this table of
Yeah,
it would be
I
string A
understand. I
this
think
way
what-
and then string B down.
I always get confused with the direction of these things, but I understand the
Yeah.
goal of this length string A and length string B. Basically, create a table that stores some of these
Yeah.
values.
Yeah, exactly.
Yeah.
Yeah, and then in order to store that here, then we would want to create like the index A, index B. These might be backwards, but we would want to store that essentially. And so then we'd want to add a case of like if like this memo
Yeah.
at index A, index B, these might be backwards again. If that's -1, then we want to return, or sorry, if that's not -1, then that means that we've already found the answer, so then we just want to return whatever we've memorized there.
Cool.
And so then at the very end, we'd want to just return memo like that. And let me just think about these indices quickly. So the first one is string B. So actually, if I just swap these two, that should make it work. Because first we'd index into A and then we'd index into B.
Yep.
So yeah, if I just swap those two, that would work.
Cool. Yeah, this makes sense to me.
So, yeah.
I guess my last question, I think that this is the approach that I was kind of thinking about as far as dynamic programming goes. My last question is, what would be the runtime of this, memoized dynamic programming solution?
Okay, so here we are going through all of index A, or all of string A and all of string B, right, by incrementing these indices until we hit a base case. So there's no way to avoid going through both of them. And incrementing one but not the other. And so we essentially have to fill out this entire memoization table in order to figure out our answer, right?
Yep.
Which means that it would be O of n of n.
And then my last question, I know we're running right up on time, is, I guess given the context of the original problem was you might have a library of books, how would you leverage this find longest substring to, I guess, find the two most, like the highest probability matches in the entire library of books?
I think that, so here, now that we have this find the longest substring with string A, string B, and let's suppose that we changed the implementation of this book to be this like long string of characters for the content, then that means that what we can do for this find longest substring is just pass in like book A dot content and book B dot content and figure out the longest substring between the two of them, and we can do that for all the combinations of books, unique combinations of books. And if we find, for example, so the prompt is to detect the two most likely books that have plagiarism. So we would just return the two books with the longest substring. But, maybe we want to say like any books where more than 30% of the more than 30% of the book is, or maybe even like 10%, shares the same substring, then like we might call that plagiarism.
All right,
or something like
that's
that.
all I have. Thank you for your time. I guess quickly, do you have any questions, I guess for me, or any
Awesome.
questions about these prompts before I head off?
Okay, so note to the audience that in a normal interview, this would be a time when I would dive deeper and ask questions about, Keith's work or what, he enjoys about the company. And if I, find something in one of his answers that I'm really interested in, I'll dive into that a little bit more. But because this is just a fake interview and I don't really have any questions about Keith's company because the company doesn't exist.
Yep, that makes sense to me. And I did
will
not
just
give
say
you
no
any context
questions.
really to work with here. So we don't have to repeat what we did with the video that
Yeah.
posted on my channel. But cool, nice work. We can end interview. Switch gears.
Yeah.
Yep.
All right. So now let's switch over to the feedback session. Do you want to go through your notes and kind of just share what was good,
Yeah.
what was bad, your
And
overall impression?
I think this was an interesting session because I wanted to squeeze as much as possible into this. Like oftentimes you might see like a smaller, fully object-oriented design or a smaller, only algorithms, but I kind of wanted to get both because ultimately, from my perspective as an interviewer, like I
Yeah.
feel like having both concepts is how I actually evaluate your programming skills because a single algorithm doesn't tell me that much as far as your actual talents and like if you'd be a productive member of our team, and also the object-oriented design might
Yeah.
not say everything either. So I liked
Yeah.
the combination, but it was a bit like it is a lot of information. So feedback-wise, let's start with object-oriented design. I think solid overall. I think that you hit like the key points.
Yeah.
I think some of the things that I'm thinking about with regards to your solution is you hit all of like the key things that I was looking for. So like all books in library, remember active book, remember last page in all books, display a page in active book. I think you did a good job with like the basic class structure to capture all of that. I think what I would have liked to see if I was to be like nitpicky and looking for even better solutions is I might look for even further breakdown of classes. So like I think there was some things that could have been broken down further where I think maybe you could have a display class even that could kind of separate the details. Like you have the book class that has the title, the content, but then the display class can handle like the font sizes, the characters per page, all of that, and just isolate that functionality.
Yeah.
So that was like one thing that I picked up on is just I think that it's tricky in an interview setting, but I think that to isolate different components and make it easier to fit all together, I think further breakdown of these classes could have been beneficial. And then my other kind of like nitpicky comment in criticism would be like, I think the way that the IDs were structured wasn't necessarily like the most easy to understand. So I guess providing some more details on, I guess, adding robustness to these IDs. I think like one thing that would have been interesting, I guess I didn't ask about this specifically, but the concept of like, okay, how could you then maybe, if you only had a title in the book contents, how could you maybe grab that ID retroactively, or like, would you want to do that? So like maybe some more robustness in how the IDs were set up so that you didn't have to know the system to necessarily get an ID. Does that make sense?
Yeah, for sure. I definitely think that the ID part was one thing where it was like I would have rather just used the title of the book or like some combination of like the title and author. And I think like for example, at like an actual library, they have like their code or whatever, and they have their system for, you know, if it's fiction or whatever genre it is, and then like some combination of I think author that I don't really remember that they use to ID books, and I think that probably would have been like a better solution is if we had like the title and author and
it is
genre,
tricky
then
because
we
you
could
don't have
come up with
access to
something
that
based on
nice
that.
library. I think the key thing that you did well with the IDs is that you knew that had to be unique. You didn't want to have collisions, and by mentioning like titles might have collisions, that's super important because that would cause all sorts of headaches for us. Let me see what else I wrote down. I mean, again, like I'll reiterate, like this was a good solution. This was a solid solution. This would be like something I'm looking for. So like my feedback is more nitpicky and like how could things be improved further. I think another way, and this is kind of similar to breaking things out from, you know, a book class and then a display class to actually put that onto our Kindle Cloud Reader. But I think another way you could have maybe broke this down in a logical manner was when I asked that last follow-up question, which was basically, you know, you might have many users in this, and now we need to be able to, each user needs to have their own like last page for each book and all of that. I think that your answer could have been a bit more nuanced there. I think one thing that you could have maybe mentioned is we could have potentially used like superclassing, subclassing to maybe have like, you know, a base book class, but maybe there was like a user book class that built off of that class book that, you know, everyone shared ID, everyone shared title, everyone shared content, but all of those user specific things could have reused some of that previous code but built off of it. So that would have been an interesting idea too.
Yeah.
That's all I have for the
For
object-oriented portion. Any, I guess, other comments on that section? Cool. And then I think for algorithm solution, I think throughout the interview you did a good job of explaining your thoughts. Super, super important to anyone listening to this. Don't just write something down. Talk through what you're writing down as you're writing it. That helps me make sure that I know what you're talking about. That makes sure that I know that you're on the right track or off track. So you did a good job both in the object-oriented design as well as the algorithm, just explaining what you were thinking and the pros and cons. So like one thing I liked in the algorithm section is, you know, coming up with a very naive solution to start. I like seeing that kind of iterative approach, see that you're kind of working towards more optimal solutions. So I liked the idea of using like every single substring in these two, but then realizing this is not optimal. I liked then you kind of building and taking that and being like, okay, maybe that's not the best approach, but let's take a base sentence and a new sentence, and start going character by character in the base sentence and compare it to the comparison sentence. I think that was you're working towards a better solution. It's going to be better than that every substring approach, but still not quite optimal, and kind of realizing that there was more improvements that could be made. There was a challenge in how to get to the dynamic programming solution. I think we maybe lost some of those details you would normally have included on like the nuance of this and how you might improve it. So like I would have also liked to hear mention not only of verb tense, but also like punctuation if we have to keep that in mind. So if someone changed periods to exclamation points, should those still match or should they not match? All of that. And then just kind of getting to the dynamic programming. I think this was definitely like a challenge trying to figure out how to formulate this. So I definitely had to help a bit more. I think in an optimal, like perfect run through, you would have gotten a little bit further without me having to prod. But I think the nature of dynamic programming is unless you're reviewing it and like really like studying it and staying on top of it, like in the real world, you don't have to know this type of stuff. You're not coming up and like designing from scratch dynamic programming. You're usually looking at notes and all of that. So like I was, I'm okay in an interview setting having to prod a bit, but that's I guess a difference between a good interview and a perfect interview is like the nature is I had to provide a decent amount of details and kind of help you get to a recurrence. And then once I gave you that starting point, the launching point of the recurrence, you did a great job running with it. That was definitely like the optimal longest common subsequence or substring type of solution with recursion and memoization to help get us to the optimal. So it was nice to see that once you had an idea of what we needed to do, that you were able to run with it and knew exactly where you could implement an optimal solution. I think that's all I have. I'm rambling on a bit, but hopefully those notes make sense, and I think we can further discuss.
Yeah, I definitely think that this longest substring was a slightly more challenging problem based on like, the problems I've done on LeetCode or like the ones that I faced in like actual coding interviews. But that's not to say that it's not like a good problem, right? I think it's a really good problem to ask and to kind of figure out, what are my strengths and weaknesses. And I think that one thing that you probably learned from this is that, okay, maybe I have certain ideas that are there and that I like needed a little push in trying to formulate it properly. But then once you gave me just like a structure to formulate it, then I was able to take that and be able to run with it, right? Which I think that, from an interviewer's standpoint, like when you're interviewing, it's not just about can they do it or not. It's also about how would they, what would an interaction with this person look like, right? And so actually one thing that I really liked about this was that it seemed to be pretty collaborative, and it seemed to be very casual rather than like me taking a test. And so, what that tells me as somebody interviewing is, oh yeah, like if I do get stuck, like this person would be able to give me a hint, and then I would be able to take that hint and do the rest of the problem.
This timing is perfect because my food is here. I'm going to eat and then be back. Definitely help. Hours. Yeah, I'll eat and then I'll. No, I will eat and then I'll exercise. Then I'll probably play the game and then I'll probably be back. But I'm probably gonna start getting. Well, it looks like I'm getting more time in. Oh, yeah, definitely need to exercise and eat.